Hello everyone. Now we are going to solve Advanced Paper 1, Section 2, question number 14. In the following reaction sequence, the major products X and Y are acyclic monomers. First sequence I've given, that is methyl iodide on treatment with a series of reagents, we are going to get X. Okay, so these are the sequence. Next, we have caprolactam, that is on acid hydrolysis, gives Y, that I have written here. Then 500 moles of X is completely reacting with 500 moles of Y to give 1 mole of a single biodegradable acyclic copolymer of Z as the only product. The amount of Z formed in grams, you have to find it out. They've given atomic mass of carbon, hydrogen, nitrogen and bromine are given. Okay, now let's see what is a sequence of reaction. First intention is to get the values of X and Y. Okay, so when you know the monomers, then we can just find out what is the amount of polymer which is formed. First is you have methyl iodide. Methyl iodide on treatment with KCN. Okay, so what is the reaction? This I minus is replaced by Cn. Therefore, you are going to get CH3Cn. That is, nitriles are formed. So this is on hydrolysis, acid hydrolysis, H3O plus on heating. What is the product we are going to get it? Nitriles on hydrolysis will give you acids. Okay, so now we are going to treat this with red phosphorus, with Br2. Now what is the reaction? So this is nothing but this is a functional group. This is the alpha carbon. This alpha carbon has a hydrogen atom. Alpha hydrogen is there. Therefore, it can undergo HVZ reaction. So that is the alpha hydrogens of carboxylic acid are replaced by halogens. So here the halogen is nothing but Br. Therefore, we are going to get CH2Br, then this is nothing but COOH, you're going to get it. Okay, so this is the reaction, third reaction. Next, this is again on treatment with ammonia. Again, they have mentioned that it is in excess quantity. We know that this is acidic in nature and you're adding a base. There are two types of reactions which can happen. One is this acid reacts with base to form a salt, and also this Br is replaced by NH2 group. Therefore, we are going to get CH2, then this is COONH4 plus, that is a salt. Then this Br is replaced by NH2 group. Okay, then they've given that on hydrolysis. Okay, X is again you have to hydrolyze this. When you hydrolyze this, you're going to get it as glycine. Glycine is NH2, CH2, then you have COOH. COOH. Okay, so we are going to heat it also here. We are going to hydrolyze it. So you're going to get glycine. Okay, so this is X. Now they're saying this is a monomer. We need the molecular mass of this. So therefore, molar mass of this glycine is nothing but you just find out. So it will be 7 plus 12 plus 12 plus 16 plus 6. Everything when you calculate it, you're going to get it as 75 grams per mole. So this is the molar mass of glycine, 75, you're going to get it. Next, they've given to get Y, we need to take caprolactam on acid hydrolysis. When I say caprolactam, it is a cyclic compound. Lactam means you have C double bond O and NH group will be there. Okay, so now it has got 5 carbon atoms, 1, 2, 3, 4, 5. Okay, so therefore we are going to get it like this. Let us count it again. 1, 2, 3, 4, 5. So this is caprolactam. This is on hydrolysis, acid hydrolysis, again on heating. So the breaking of this bond will be taking place. NH will be converted into NH2. Again, the CO will be converted into COOH. Therefore, I'll write it here. So NH2, this is NH2. Then you have CH2, 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 CH2. So that is repeated for 5 times. So CH2 5 times. CH2 5 times, and you are going to get it as COOH. That is nothing but 6 amino hexanoic acid. 6 amino, this is the first carbon and you have 5 here, and in the sixth position you have an amino group, that is 6 amino hexanoic acid. Hexanoic acid. Hexanoic acid. Therefore, this is nothing but Y. Now let us find out the molecular mass of it. The molar mass of Y was found to be 131 gram per mole. 131 gram per mole. Therefore, what we found out was X is nothing but glycine, Again, Y is nothing but 6-amino hexanoic acid. So we need the molar mass. We have already got the molar mass of this. Let us continue the question by reading the remaining statement. They're saying that 50 moles of X reacting with 50 moles of Y to give 1 mole of a polymer. That is 500 moles of X, 500 moles of X, 500 moles of X plus 500 moles of Y to give 1 mole of polymer. 1 mole of polymer. This is what is given. What we know is the molar mass of X. This is X, no? X molar mass is 75 gram per mole, and molar mass of Y will be, molar mass of Y is equal to 131 gram per mole. Okay. So now whenever there is a condensation, the definition of condensation is two or more molecules which are combining to to form a long chain compound by eliminating a simple molecules like water, ammonia, etc. Now, in this case, you can see that you have a glycine here, NH2, then we have CH2, COOH like this. And in 6-amino hexanoic acid, we have a NH2 group, then we have CH2 5 times, then we have COOH like this. Now, what can be eliminated here? H2 plus O will be eliminated as what? Water here. Okay, so hydrogen from here and OH from here, it will be eliminated as water. Therefore, here the elimination of simple molecule is water. Water is eliminated. Now we have seen, we know that if there is n number of monomer, then in the when it undergoes condensation reaction, then the amount of simple molecule eliminated will be 1 lesser than that. It will have n minus 1 compound, but 1 molecule of water will be lesser. Therefore, I would say that something like this. We shall find out how many moles of water it is eliminated. Therefore, moles of water eliminated. Moles of water eliminated is equal to how many moles? Total monomer will be 500 plus 500. 500 plus 500, that's equal to 1000. Okay, minus 1. Why? Because at the end you have COOH and NH2. Those two will not eliminate the water molecule. Therefore, the number of water molecule eliminated will be 1 lesser compared to the monomer. Therefore, this is nothing but 999. 999. Let us find out what is the mass of water, because mass of water eliminated, because we need to find out the mass of the polymer. We need only the monomer mass. We don't want this mass of the water because that is getting eliminated. Therefore, this is nothing but 999 into 18. 999 into 18 is nothing but 17982 grams. 17982 grams. This is the mass of water eliminated. Now, let us find out what is the mass of monomers. What is the mass of monomer? There are two things here. Okay, so one is 500 into molar mass will be 75 plus 500 into molar mass of Y is nothing but 131. Therefore, when I simplify this, we get 35500 grams. 3500 grams, plus if I look at this is nothing but 65500 grams, 65,500 grams. Therefore, when I simplify this, we get it as 10300 grams. That is 1,03,000 grams. This is the mass of the monomer. But what is the question? The question is mass of the polymer, right? Therefore, we took this much mass of monomer, out of which this many grams of water is being eliminated. Therefore, the mass of polymer formed is nothing but the total mass of the monomer minus the mass of water which is getting eliminated. Therefore, mass of polymer is equal to mass of monomer. Okay, monomer, mass of monomer minus mass of water which is getting eliminated. Therefore, mass of monomer is nothing but 10300 0 grams. Okay, 0 0, I'll write it, 14000 minus mass of water is nothing but 17982. Okay, therefore the when you subtract this, you will get it as again 850 85018 grams. Therefore, this is the molar mass of the polymer. So in this question, we got to know that what is X, what is Y, then when they combine. So they undergo condensation. During condensation, simple molecules will be eliminated. Then if there are n number of moles, then the number of water molecules eliminated is nothing but n minus 1 that we have calculated. If it is 1000, then it will be 999. Then we found out the mass of water. Then we found out what's the mass of monomer. When we subtract both of them, we got the mass of polymer which is formed. Thank you.